Hello. Okay, so let's start from the beginning. Not from the beginning, not starting from the beginning, but I'll give you a short summary. Okay. So okay, let's go step by step. So we're still in this is the second episode of answering the question of, is there a better time to buy Bitcoin? So we are looking for, is there a better time of week, month, maybe year, okay, of buying Bitcoin? We imply with that so what does means is there a cheaper time for Bitcoin to buy? So better means cheaper actually here in this context. And we have a null hypothesis. So we are hypothesis testing. And the null hypothesis here is, if you're testing for the day of week, every week will the Bitcoin price fluctuations has no bias toward 1 week. Like it's not, it doesn't provide you any advantage on buying that one specific or a few specific days. That's the null hypothesis. Every day, buying every day will generate the same result. Buying on each day, sorry, will generate the same result. On the other hand, our alternative hypothesis is there's a few days that the Bitcoin price is cheaper. And if you think this as a long-term investment, this will be more beneficial to you if you're, if you're scaling in, if you're buying, let's say you have $100 and every month you want to put $100 into Bitcoin. And if, let's say, this weekly analysis finds a statistical significance that 1 day of week Bitcoin is statistically significantly cheaper than other days, then you would prefer to buy on that one specific day of each week. So you split your money into 4 for each week. So $25, you invest in $25 each week on that specific day. You can do this for month. What month of the day the Bitcoin is cheapest? You can look for a statistical significance if there is. You can do this for, okay, what month of year Bitcoin is cheapest? So that's the idea. I'll first do this for weekly. What day of week is Bitcoin cheaper than the others? I have to state clearly that this is not an investment strategy or idea for anyone. Okay, so I'm just learning data science. This is a data science project, and to me, the best projects are those that teaches you something new, and that is something that you're curious about. And finally, it is something that a data scientist would need in future. So it's the intersection of this tree. So here, I found a data set on the internet. I'll use it to do my analysis. So I have to rearrange this data set. I'm practicing my pandas skills. And so far, I haven't used any statistical packages. This will be an introduction. I'm thinking from my past knowledge, I can use chi-square test to test the results statistically. This is definitely not an investment, suggestion, opinion, anything, okay? Do your own research and make your own decisions. Okay. So what I have done so far is I uploaded packages. I think we're going to change this with SciPy shortly. So we upload packages. This is the name of our data set. This is the path. So we assign the path to the file path object, and then we read this from we read this into the data object, and this is our data, what it looks like. So if you remember, we had some problems with the prices because prices are strings and we can't do min max type of queries or searches in the price subsets. We will come to that later, but here I changed a part of the code. Instead of dropping columns in the original data set, because I decided to just pick a subset and do my analysis on that subset. So I decided not to change the original data set. Okay, I'm still going to rearrange. So, okay, what I'll do is I'll get this. Previously, this was data. Get this up here because even though I'm going to use a subset, I want to make this arrangements on my original data set. So this code here creates an empty string, an empty list, and here I create the list for days. So this is it. July 18th is Sunday, and then July 17th Saturday. So my idea, what I'm thinking is, I write a loop, and this loop create me a days list with the days in order as in the data set. So Sunday, Saturday, Friday, Thursday, Wednesday, Tuesday, Monday, and then starts over. So this is how I constructed the loop. There might be an easier way, but I don't know. So this generates more than enough days. So I delete some of those rows, and then this will, so my data has a shape of 4,005 rows and 7 columns. And this gives me 4,004. Before I drop the column here, I'm going to start from this. Okay, now they're equal. And then this will insert days. Oh, this changed. Oh no, okay. Good. this anymore. This can go up here. The reason I do this because these names with period in or has space, they are not ideal for filtering data. For example, you can do this. This won't work. You can do this, which works, but you know, sometimes the code is cleaner to me when you do the one or the other. So I just want to have my options. I just want both to be my options. So this is why I opt in for such a change. And I also want to see this change. We do this and we have our days. This will help us to select the subset. Need this anymore, we don't need this anymore. This will help us to clean up the data. I'm wondering if I can put this as a list and do this in one line. First, let's try something else. So this works, but the other one doesn't. Interesting. Anyways, we tried. Okay, let's gather them up. So, so this will help us to get a subset of data, okay? Okay, I want to make this a bit more convenient. The reason is we're making a weekly, we're looking for the cheapest day to buy Bitcoin in each week. So the number of rows we're selecting for our subset should be 7 times some integer. Okay, the mode of the number of rows should be 0. And if someone else wants to do it, and the reason I'm selecting a subset is first, in the beginning of the Bitcoin history, in the beginning of the Bitcoin the price was not fluctuating much. So when you, so like for 1 week, the price stays the same. Honestly, it actually fluctuates, but my current data set doesn't reflect the, it only reflects price fluctuations with one floating point. And I'm not sure if this data, let me check. So the data set, is it designed this way? I'm checking. It seems like, yes. Therefore, price, okay, I can show you it on the actual data set. You see that? So if we include, and if you go check the BLX, which is NASDAQ, Bitcoin, Brave, Bitcoin, something, something. And if you go check that, there's actually, the data, the price is represented by two floating points. And it's not, this data set doesn't reflect it. So if I include this part, I think what the min does when you want Python to bring you the minimum for each week, what's going to happen is it's going to bring you if all the dates, if the Bitcoin price is the same for every day, it will bring you the minimum. It will look for the minimum. It will see that it's all minimum. It's all the same value, and it will bring you the first one. So this will skew our results. So we don't want that. For this reason, just instead of going and looking for another data set, I'm just going to skip to the part where Bitcoin price fluctuates every day. At least the data represents those fluctuations. So we can start somewhere around here, around 3750s. But remember, for the analysis to be, I just want to look weeks, not, like I don't want to exclude any day for any week. If I put some random number, it might be that I cut the data on Tuesday and we have more Tuesdays and Mondays than Sundays and Saturdays. So I don't want that. It won't make a big difference, but still, I want this to be proper. So for that, what I'll do here, we want to what is the cheap. Do this. Um, should categorize the data quickly, and to do that, we which what days belong to this week. So we're gonna come down, use this code. We sign and economy. Indicates what is not very good language skills, I guess. So what this will do, this will generate a weeks list that is a list comprehension, and in this list comprehension we have two loops. The first loop will put a number starting from 1. This is the other loop. This will, for I, this will loop from 1 to the length of data divided by 7, because it's how many days in a week. And this is basically how many weeks of data we have in this data set. And plus 1 because the last value of range is not included. So this is essentially what we are doing here. And then for j in range 7, what this will do is if I is 1, it will start with I, and then we'll go to the next loop, and this j loop will go from 0 to 6, so it will repeat it 7 times, and what it will do is it will print I for 7 times. So 1, 1, 1, 1, 1, 1, 1. Okay, and then we'll do 2, 2, 2, 2, 2, 2, 2, etc. This we might get an error because we get an error. So a good idea. So we're missing 1. We're missing 1 day. And for this, what we can do this, we'll insert it. Yes. Okay, this is better. Now, this is the time where we pick the subset. Let's check. Um, proper. Yes. So if we include is from the very beginning. Our result. Um, 0.1. What happened? For 13,791, 14,798, 98 plus 7, 105. Well, this means day. Okay. So it will be like Monday, 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 Monday always. So we'll get like 15 Mondays in our data set, which is actually not the case. This is not realistic. This will therefore, instead of we will exclude, we will a subset of the original data set. Our analysis over. This the behavior of the food so we can run this analysis. As the sample size statistical significance is likely to get impacted for enough of sample. What does enough mean? Easy. But it is mhm. I will try to actually the statistical test checks for it. So we can we shouldn't worry about it too much, but yeah, this might be a problem. Okay, one step at a time. So let's create a code snippet so that we enter to exclude and data and and so equals not days, not days. exclude equals 15. Subset is data dot query equals week less than bum, 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 bum. Why minus one didn't work? Okay. Then we do next. Okay. Name no weeks is not defined. Are you kidding? Okay, this does the job. Okay, so this will do is this will bring the minimum price. This is the chart, okay? So ignore this. This is just to see, but this is what we see. This is a pretty significant difference. So next time I have to go because I have a meeting at 11, but next time when I'm back, we're going to run a chi-square test. There might be a better test, but chi-square test basically assumes, so you can do this, first of all, you can run this test on categorical data. So here our categories are the days of the week from Monday to Sunday. And chi-square test assumes there's an equal chance for each day to price to be the cheapest. So the expected value, you have an expected value, which is the total number of days divided by 7 for each. And then you have the observed values, which are these here. So I'm going to put the equation to calculate the chi-squared. But what's going to happen is we're going to calculate chi-squared value, and then depending on the degree of freedom, we are going to find a p-value corresponding to the chi-square, corresponding to the degree of freedom. And in our case, degree of freedom is there's 7 outcomes of this process. So the price has there are 7 days for price to be the cheapest, so 7 outcomes. So degree of freedom is calculated by df minus 1, so 6. So for 6 degree of freedom, we're going to find the chi-squared, what it should be. And if the calculated chi-squared, what we calculated, is higher than that threshold chi-squared value, means that there's this statistical significance saying that by looking at the Bitcoin price history, seems like Mondays are cheaper to buy Bitcoin. Okay, but this will happen in the next round. So until then, I see you later.